Hello and welcome to Nunley Math. I'm your host, Aaron Nunley. I want to thank you for joining us today as we are working our way through Algebra 1. We finished up our unit where we talked about solving equations. We're now looking at applications of equations and how we can model real-life problems using a variety of different problem-solving strategies. Today's lesson is going to focus on percents. Of all the patterns we work with, percents tend to be I don't want to say not as challenging, but I suppose a little less challenging than some of the others because of the familiarity we already carry with us regarding percents. So hopefully you'll find this to be one of the easier patterns to work with. Once again, we are going to move from the simplest types of examples into more complicated examples. Some of the ones towards the end can be a little bit rough, but if we develop this incrementally, starting with things that are fairly straightforward, I think you'll find that you can do this without a whole lot of trouble. Now, I will tell you, there are two major types of percent problems that you are likely to encounter. We are going to look at both of those today. We'll do 4 or 5 examples of type 1 and 4 or 5 examples of type 2 as we go along the way. The first type is this right here. You're often told that some part is some percent of some whole. Some part is some percent of some whole. This is a very, very common pattern. In fact, when we first introduce word problems in that involve percents, the problems tend to look something like this. 15.5% of 60 is what number? It's a fairly simple translation problem. Now, a lot of you may have solved these in the past using proportions. Certainly you can do percent problems using proportions, but I'm going to show you an alternative method today using the translation strategies we have used in the past. In this problem, we are told that 15.5% of something is going to be another number. In other words, if we take this whole amount right here, this 60, and we remove or find 15.5% of it, it's going to be a certain value or a certain number. And I don't want to go too far into the basics of how percentages work. I'm going to assume you know that. Our focus today is on the translation of this. What I want for you to understand most importantly, though, is this. This phrase of 60 right here tells us that we are looking for a part of this whole. The word that follows of is always the whole thing. So we're finding a piece of 60 and we just want to know how big that piece is. Sometimes when I read this, instead of thinking of 15.5%, I actually think of the word part because a percentage is just a way of finding a part. We're trying to find part of 60 is what? And I like this particular phrasing because it reminds us that we're trying to find the part. The part is what? So when I go to use this strategy right here, some part is some percent of some whole. I can think back to our first lesson on translating algebraic expressions and equations. And I can think back and remember that this word is right here is our verb or our predicate. This is going to be an equal sign. And we also know that when we take a part of something, the word of acts as a multiplication problem. So when I receive a problem like this, I always begin with this in mind. Our part equals a percent times a whole. There again, this is just a translation of what's written up here at the top. The part is a percent of the whole. When I read this, notice that we're trying to find what number? We're trying to find that part. Because of that, I'm going to call that an x. We know there's an equal sign. What percent of the whole are we looking for? That's 0.155. Notice I wrote that percent in decimal form. We always write these in decimal form when solving problems. And of course, it's a part of 60. So this percent of 60 is what? Or my part is a percent of the whole. That's the difficult part of the problem. The solving of this is really just a little simple computation. Comes out as 9.3. 9.3. Here's another type you might see. 24 is what percent of 120? Or as I like to read it, 24 is what part of 120? Notice in this problem, we still have that of a number. So we're looking for a portion of 120, but this time the portion we have is given to us as a number instead of as a percent. Look at this phrase, what percent? The percent is the thing that's missing in this problem. So when I take this same pattern, I know the part is the 24. The 24 is equal to some percentage or some fraction of the 120. Here again, I can solve this using a little simple division, and I get x equals 0.2. Now, because we're looking for a percent, we do need to convert that back into percent form, which is 20%. Notice in the equation we want our percents written as decimals, but when we're coming out of the equation we definitely need to turn them back into percent form. You might have seen a problem like this. 25% of what is 34? Or sometimes I will read this as part of what is 34. The thing I want you to recognize here is of what. The thing we're finding a part of is the unknown. We don't know what the whole is. I'm looking right after the word of. The whole is what's missing. So when I set this up as part equals percent whole, I know my part is 34 equals, I know in percent form as a decimal that's 0.25, and the whole is unknown. This I can solve fairly simply using simple algebra. See how that works? This I went through pretty quickly because, in all honesty, we have a tendency to do a lot of this kind of problems where we're doing the direct translations, but we're not really seeing the problem in context. What I'd like to spend the majority of our time talking about is how these problems might look in real life. Here's an example of this. The tax on an automobile was 7%. What was the price of this car if the tax was $3,500? Notice I'm trying to find the price of the car if the tax is $3,500. What I do know is that the tax was 7%. This 7% of the price is the $3,500. I'm going to go back to part equals percent times whole, and I'm going to ask myself, in this problem, what are my parts and my wholes? Well, the part is the tax. Notice it even tells us the tax on an automobile is 7%, or 7 pieces out of 100. That tax is a percentage of the entire cost. Notice it's still a part and a whole. I'm just being specific about what that part and that whole is. So I'm going to fill in my numbers. The tax on the car is $3,500. The unknown value, let me back up, the percent that we pay in tax is 7%. The unknown value is the price of the car. Notice I did define my variable. I almost forgot to mention that as we were going along. Once you know what your parts and your wholes are, and you know the part equals percent times whole pattern, these are pretty easy to set up. And once they're set up, we just solve them with a little algebra. And of course, I'm going to answer in a sentence. This car happens to cost $50,000. Now, there are other ways that these problems can be set up and solved. What I like about this is once we recognize this part equals percent times whole pattern, it really doesn't matter which piece of information is missing. All that does is change where we place our x. It doesn't change the setup of the formula, which makes it very, very convenient. Here's another one. Mr. Nunley has 3 0.4-ounce creamers in his 32-ounce coffee. What percent of his beverage is cream? And it looks like it added a little symbol in here, so that's humorous. Anyway, notice what it says. I have 3 0.4-ounce creamers in my 32-ounce coffee. The question is, what percent. So the percent is the thing that's unknown. But I'm finding a percent of the beverage. So the beverage is my whole. What percent of this whole is the cream? The cream is the part I'm looking at. So when I see my part equals percent times whole, what I'm saying is the cream is a certain percent of the total drink. Now, how much cream was there? Well, the problem says I used 3.4 ounce creamers. That's 1.2 ounces. Notice I defined the variable as the percent. 3.4 ounce packages. That's equal to what percent? Well, that's what we're asked to find out. And it's a percent of the entire drink. How much drink is there altogether? 32 ounces. Notice now it's a simple equation. How do I get rid of times 32? Division. It comes out as x equals 0.0375, or using my symmetric property, 0.0375. Remember, we're asked about percents. This is given to us in decimal form, so we need to convert that. This is 3.75%. For those of you that are a little unsure, remember that to turn a decimal into a percent, you just move the decimal 2 places to the right. Notice again, I gave my answer in the form of a sentence. Here's one more. I would suggest trying this on your own. Maybe pause the video, try and set this up, and then restart the video to see if you're doing it correctly. Here's what I get when I do it. A salesman received a $750 bonus with her monthly paycheck. Her regular monthly pay is $2,500. What percent of her pay was her bonus? Notice that last sentence. What percent? We're looking for the percent of her pay. So we're looking for a percent of this total, the total is her pay, was the bonus. So the bonus is what we're finding in percent form. So let's set that up. Part equals percent of whole. The part is your bonus. That's equal to a percent of her pay. In this case, we're asked to find the percent that is the bonus. So let's go through and fill this in. The bonus itself in dollar form was $750. That's equal to an unknown percent of her total pay. What's the total pay? $2,500. This I can solve pretty easily. Divide both sides by 2,500. X equals 0.3 or x equals 0.3. And of course we want to turn that back into a percent by moving our decimal 2 places to the right. Make sure, of course, that you give your answer in a sentence. Last chance for type 1. Last chance for type 1. You estimate that tuition is only about 65% of your total cost for attending college. If the average cost of attending a 4-year college and paying in-state tuition is $23,890 per year, what would you expect your total cost to be to the nearest dollar? What I'd like for you to do is pause the video, try this on your own, see if you can get that set up and solved, and then restart the video to see if you are doing it correctly. Here we go. My part is a percent of my whole. The question says, if the cost of attending and paying in-state tuition is $23,890 per year. That's the tuition cost. What would you expect your total cost to be? So the tuition is 65% of the cost. The tuition is a percent of the cost. Do we know the tuition? Yes. Do we know the percent? Yes. Do we know the total cost? No. That's what they ask us. So the total cost is our unknown. Let's fill this in. The tuition, $23,890, is 65% of the cost. And now we just divide both sides to solve. Comes out as $36,753.85. And of course we would give that in a sentence. Now, notice the question asks what it would be to the nearest dollar, which means we really need to go back through here and round this off to $36,754 even. Okay, here's type 2. Type 2 says that some starting amount is going to get increased or decreased by a percent of that amount, and it's going to equal a new amount. I usually write it out like this. New equals original plus or minus some percent of the original. Here's an example for us. A Fitbit usually costs $80 at Best Buy, but the price is raised by 15%. What is the new price? What is the new price? So let's bring down our pattern. In this particular problem, we're asked to find the new price. So that's going to be our variable. That's easy enough. The new price, which I should have used an in for both. Let's change that real quick as well. The new price, there we go. The new price is, how much was it to start with? It was originally $80, but I'm going to raise the price. Notice that sometimes the price will be raised and sometimes the price will be lowered. But I'm going to raise it by 15%. Now, a percent is always a percent of something. When we do percent change or percent increases or decreases, it's always a percent of what it originally was. In this case, we already said the original was $80. So it was $80. I'm going to raise it 15% of $80 to find the new price. In this case, 15% of $80 is a $12 increase, which means if it was 80 and it goes up by 12, the new price is 92. $92. Give your answer in a sentence. Now, there are lots of ways to do percent change problems. I know these as well can be solved as proportions, but I find that if we can get a model in our head that we can always go back to and refer to when solving a problem, it tends to make these a lot easier for us to do, especially early on. Here's another one. You might want to try this one on your own if you think you've got this. The new equals the original plus or minus a percent of the original. A pair of Beats headphones usually costs $279. Usually cost is a way of saying this is what it ordinarily is or what it was when we began. But they are now on sale. The fact that they're on sale tells me the price should go down. And they're on sale for 20% off. What is the sale price? Notice the question in our sentence tells us what it is we're trying to find. It's our variable. So in this problem, the variable is our new price or our sale price. Let's walk through the pattern. The new price or sale price in, there again I should have started with in, is equal to the original price. Do you know what it was originally? $279. In this case, the price is going to go down by 20% of the original price. Notice the percent is always a percentage of what the price was at the beginning, not a percent of what it was at the end. This is nice because our variable is already by itself. 20% of 279 is 55.8. Subtract, and there's your solution. The new price of the Beats is $223.20. $223.20. Not bad, right? I don't think so anyway. How about this? Following an increase in wages for its workers, a fast food restaurant raises the price on its value meals from $4 to $4.50. What was the percent of the increase? Notice what the question asks us. We're finding the percent this time. I would suggest starting with the formula and trying this on your own before you watch the rest of the video. Okay. Since I'm looking for percent increase, I want to know what was the new price of the value meal. Well, we're told it was 4, now it's 450. The new price is 450. That means it originally was $4, but the price went up. How much did it go up? Some percent of that $4. Remember, the percent is always of the original price. This is a fairly simple, it's a two-step equation to solve. I'm going to subtract the 4 from both sides, divide both sides by 4 or multiply by the reciprocal, and you get 0.125. Symmetric property to turn it around, and of course we need to turn this into a percent. Remember, to turn something to a percent, you multiply by 100 or move the decimal 2 spaces over. This is 12.5%. The price was raised 12.5%. All right. This, by the way, is our last example. So I would once again recommend pausing the video, trying it on your own, then watching to see to make sure that you have this down. It says, following an 18% rate hike, the cost of your home internet service was increased to $145. What was the original price? Notice the question asks us for the original price. So when we go to set this up, the original price is going to be our variable. Notice I forgot to change that. This should say original price. That's what happens when you do too much cutting and pasting. So I can write this original. There we go. The original price. And let's see if we can get this worked out. Do we know what the new price is? Well, certainly. It increased to $145. That equals the original. Do we know the original? We don't. We just said that's the variable. But we do know the price increased by 18% of whatever that original price was. Notice this has 2 x's in it, but that's okay. We can just combine our like terms using the distributive property. Use a little division, and we come up with $122.88. And we give the answer in a sentence. The original price was $122.88. There you go. I hope you found this helpful. I find that especially for early learners learning to solve word problems, having patterns to begin with, it really increases their ability to organize their thoughts. So my strong recommendation to you is that you learn both of these patterns, both the new equals original plus or minus a percent of the original and part equals percent of whole, so that when you're beginning to attack these problems, you at least have a starting point for where to fill in your information. As always, thank you for listening. I hope this was useful to you. If you found it to be useful, please make sure to like and subscribe and turn on your notifications so you can follow us as we work our way through Algebra 1. If you have some suggestions for how to improve this, or if this has been valuable to you, please take the time and leave us a comment in the comment section as well. As always, I appreciate you watching. Thanks for your time. Best of luck to you guys. You all take care. All right? Thanks. Bye-bye.